So one of the things that makes Raman spectroscopy useful is that the selection rules are different than for infrared spectroscopy. So if we're measuring something in the infrared, we need a change in the dipole moment as the molecules vibrate. For Raman spectroscopy, instead, so IR is change in dipole moment as molecule vibrates. That's the requirement to observe infrared light being absorbed. For Raman spectroscopy, on the other hand, it's a change in polarizability that is required. Polarizability being how easy is it to polarize the molecule or induce a dipole moment. And these in general will not be the same. And so you may have vibrations that are active in the infrared where you can observe them that are inactive in Raman spectroscopy and vice versa. And these are often will be different transitions. And so, when you look at a Raman spectrum, it's going to look something like this. So if we plot, intensity of light on our y-axis and frequency on our x-axis, so we'll see a huge peak from the Rayleigh scattering, and this is at the same frequency of light as we have incoming from our laser. Usually this will be laser. At lower energy, we'll get peaks from our Stokes scattering, where the molecule has gained some energy and the photon has lost a little bit of energy. And to the right, we'll see, and usually this will be weaker in sort of a mirror image, this will be our anti-Stokes. And when we measure Raman spectroscopy, we usually look at the shift, right? What's the shift here? The Raman shift is directly related to the energies of our vibrations. So just to show you an example of how this looks in comparison, when we compare these two, if we measure, say, the same molecule, let me go over to my PowerPoint slides here. So this is an infrared spectrum and a Raman spectrum of benzene. So looking at the Raman shift for the Raman spectrum and then the infrared spectrum, this is all the absorptions. So we can see these spectra, while both looking at vibrations of benzene, give very different results. So we see, there's lots of peaks that show up in the infrared spectrum that are not present at all in the Raman spectrum, and vice versa as well, right? So there's a little bit of shift between these two vibrations here. We get a different, set of CH stretches out here at the 3000 wave number range, right? And so you get complementary information from the Raman spectrum based on looking at the Raman shift.